So for those of you guys just joining us today, you're absent or you didn't come to the period or you're, I don't know, busy with something. We just made sure everyone could log into their AP Classroom, that they knew how to access the assignment. What I was talking about when an assignment that's been on the board actually all week, but sometimes it's been on the side, and I said MC, multiple choice. When that's on the board, what I'm talking about, there's something that's been assigned. But then we also were talking about how we needed to figure out how to see your results so that you could go ahead and see what you got right or wrong and come in with questions, because whether or not I said it earlier, this process is kind of tedious, right? Like everyone logging in at the same time on your phone in a classroom, which to be frank, in that back corner is kind of like a dead zone. I think it's because of like the brick and the structure and whatever. But anyway, what would be easier? The day after something like this is due, what if you screenshotted the ones you got wrong? Right? You wouldn't have to worry about connecting. You wouldn't have to worry about logging in. You wouldn't have to worry about, etc. I mentioned earlier that in this technological age, as you're taking it, and I realized some of you didn't know you could access your results, but now that you know you can and how to, right? You can access your results. You can look at your quiz, what you got right, what you got wrong, and look over it and take screenshots of the ones that you are confused on so we can go over them together in class. Sound good? Okay, but for today, since we haven't been able to do this yet, on Monday we'll go over any other ones that you guys want to see, but let's just go through the ones where only 1 or 2 people got it right. So what was your guys' rationale now? Whew, there's a long paragraph for what's going on. What were you given in this function? Or in this problem, I should say. This big old nasty bleh. Hold on, where should you be doing work for these assignments so that you can access and correct grade check?
Good morning.
Oh, good morning, sir. Yeah, that's you. Thank you, Mr. Ratchet. And I got some change from Leslie, so I'm ready for the quarters. Ratchet bread is $1.25.
Yeah,
so
and needless to say, whatever you collect here stays from Abby.
Okay, perfect. Thank you, thank you.
This is your first period.
Yes. I know, we were going to talk about that.
I am very proud of all of you for doing this.
Sorry,
Does anybody need some money to go get some coffee? I will give you the money.
And this assignment's been due. We're just working out the kinks of something new. Where did I tell you guys to be doing work?
Oh, back home.
Awkward. Yeah, back at the homework spiral where we always have our workspace. Now, I can tell by no one having it open today, maybe we didn't do that. So, for the future, when an AP Classroom is due, you're going to have it done by the deadline, and then you're going to check the results. Does that make sense? I have no way of making sure that you have it done and you checked the results by the deadline, but we will be going over questions the next day, whenever that is, and screenshots will be preferred, for sure. And you guys having already thought through will be preferred. But maybe you'll have group time like this, where you just have the screenshots of what you got wrong. You can talk it out. How did you do it right? But you're not just trying to remember what random thing was on your mind when you randomly guessed an answer. You're going to be opening up to your workspace where you have Unit 1 MC, Unit 2 MC, Unit 3 MC. Does that make sense? So that way you can access what you were thinking, what you were doing when you did these problems. Okay? Okay. Any questions about AP Classroom, how we do it, or how we're going to follow up? Are we okay? Okay. So when I grade your homework spirals, it's not going to happen this time because Unit 1 MC, obviously we were not exactly all on the same page, and I'm still learning it too. It's brand new for all AP teachers. But starting in Unit 2, it will be something I will be grading in your homework spiral, seeing if you do have the work from these checks. Well, to be honest, would it be helpful for you guys, since you're used to Google Classroom assignments, for me to make an AP Classroom Google Classroom assignment where you submit the work and just integrate it that way? Would that be easier? Okay, that way you have the deadline and you have the notification and the email and all that? Okay. And then I'll just put a link to my AP College Board so you could open up the assignment, go to the link, log in, do the assignment, and then just attach the pictures. That's okay, and then I won't have to grade it another time. Yeah, why?
So it's the pictures of back of
Of the work, yeah. Just at the And if you want to throw a comment in there like, man, this number I was totally lost on, you totally could as well. Okay, sorry. Thank you for helping me work out a lot of kinks. So, you were given a nasty polynomial, a fourth degree polynomial, which is super gross. And they said, for how many positive values of b does the limit equal to? I guess a lot of you might have had the question, can I use my calculator? That would have been a good question, right? If you could use your calculator, how could you solve this? Plug it in where? But then what, after you graph it? How do you know where the limit's going to be to? Yeah, but what's nice about this, what kind of function is it? Isn't it a polynomial?
Yes.
And for all polynomials, since there are no discontinuities and it's not a piecewise function, aren't all of the limits just going to be the y values? Right? Isn't it just going to plug in and then come out? So what can I do? Can't I find the intersections pre-calc graphing calculator handbook? Can't I just find the intersections of my function and y equals 2? How many times will the function equal 2? Just count them. 2, 2, 2, 2, 2, and guess what ends up being the answer? Now, what's one of the questions that you might not have known the answer to, and so you might not have known how to do the problem? Can you use your calculator? This is an example of when the answer is most definitely yes. Now, that's a struggle because I don't think there was anything in the wording at all that said calculator or non-calculator, which kind of stinks as far as them. That's something I should comment on the AP College Board. Be like, guys, you gotta tell them whether or not it's a calculator question. But anyway, long story short, does it kind of make sense now? What would you be looking for? How do we solve this in a calculator? How would you solve it? We don't know. Okay, that's a y1 and this is a y2. And how do we see where two functions are equal to each other? Count the intersections. There you go. That's what I was looking for. You don't even need to find them. You just need to know how many. Do you see it? Because you could graph, and then you could graph, and however many times it hits, that's how many times the y values will be, and how many times the y values will be is the limit. Or will coincide with the limit. Does that make more sense? Vicente, is that how you did it? Did you graph it, or did you do it another way?
I thought since the highest degree is 4, both sides would go up, and the amount of times it would curve is 1 less than the degree, so it would be 3 times. So that's what I thought.
Oh, got it. Okay, so he was thinking about like polynomial behavior with the n behaviors. That in general would be okay, except for just a dilemma. If this is my y equals 2, in another situation, I mean, these are small decimals, so they haven't made it off the axis very much. I mean, you guys might not be able to see that, but they haven't made it off the axis very much. But the problem is, what if, because that could be a 4th degree polynomial, it could actually hit, depending on where this was, it could hit either no times, or it could hit 2 times, or it could hit 3 times, or it could hit 4 times, or it could hit 2 times, or it could hit. So it actually ended up working for you this time, but depending on where y equals 2 goes, you could have different numbers of intersections. So good to think about the behavior, but I'm not sure it would be enough all the time because it could have hit in lots of different places. Okay, that was a tricky one. I want to go back to that. Let's just keep going forward. We got 2 people who got this one, right? Who are my 2 people? Hey, Vicente and Pico, good job. What? They're in the same group. Look at that. What's the question? Particle moving on the x-axis. Position of the particle is given by graph is speed of the particle. Oh, that's rough. You guys don't know what speed is yet, unless you're in physics. That's rough. At t equals 8, we have talked about, ready? We have talked about in pre-calc how slope is the rate of change, average rate of change. We've talked about it, but briefly. We haven't talked about motion a lot yet until chapter 2, which is what we're supposed to be starting today. So, if you had remembered from pre-cal that speed has to do with rate and rate has to do with slope, you could have looked at this and said, what's the slope? There you go. What else did we do fairly rough on? But you guys are seeing some of the reasons that we did fairly rough on it, right? Huh? Oh, here's another one. Ooh, it's a table. Look, guys, we're coming towards one from below and from above. How did we miss that one? That That means they made the other ones, Kathleen and Pico, that means they made the other ones sound really, really good. Everyone thought this one, huh? That was like the most common one, though. That was the most common one. Let's see what happened. The table above gives the values of the function f at the selected values of x. Which of the following must be true? Which of the following must be true? That's mean. That's mean. Question, why does this one have to not must be true? It could be, but it probably isn't. Why is it probably not true? What is 2? F of 1 is 2, but it looks like the approach severely disagrees with the at. It looks like the approach severely disagrees with the at. So in that case, the at is 2, but not the limit, so I would have crossed that one out. The second one, the limit, this is the one that I probably would have chosen if I was going really, really fast. Because this appears to be true, right? Appears to be true because it looks like it's going to 7, looks like it's going to 7. It's coming out of this one, the limit does not exist. Well, it sure looks like they're agreeing, so I wouldn't say that one. So now we're down to cannot be definitively determined or appears true. Guys, which one goes with must? Must is for sure, without a shadow of a doubt. I would stake my life on it. There's absolutely no way that it's weird, or I would still say. You would still say. According to what we've done in our notes, we would have made the hypothesis of the limit being 7. The problem is, whenever you do a table, it is possible. It is possible. Because they didn't tell us what type of function this is. They didn't tell us it was continuous. They didn't tell us it was polynomial. They didn't tell us the domain was all real numbers. We don't know exactly what's going on. So it is technically possible for this to appear like it's converging when it really isn't. Do you guys remember that really weird limit does not exist example of sine of 1 over x? Can you guys get your calculators out? Sine of 1 over x, that really weird one that looks like a barcode. The more and more and more you zoom in. Sine of 1 over x, that really weird one. Now, if this doesn't work, I'm going to kind of be a failure. But I think this works. Sine of 1 over x. Make sure you're in radian mode for all calculus. Sine of 1 over x. Sine of 1 over x. Now, don't go to the graph right now. I want you to go to your table. Hopefully you're in Ask. Oh, I'm sorry. We were doing the calculator worksheet last week in pre-cal. So let me get all set up. There we go. Ask. Got it. Second table. What happens if you do 0.1, 0.01, 0.001, 0.0001, 0.0001, 0.0001? What does it look like? Let's do it. Dang. Yeah, now I don't know exactly what that is. Oh. Sure looks like it's approaching to me, like it's stabilized. They're the exact same number? What? What happens if you actually plug in 0? Because remember, we're getting 0 closer and closer and closer to 0. How does that work? Oh. But in my table, 0.1, 0.01, 0.001, 0.0000, etc. Looks like it's stabilized. But here's the problem. I have jumps by set jumps. And multiplying is actually like a geometric sequence, where I'm multiplying by 1/10 every time to get my jumps. What if I have to change this up? Okay, you guys look, it seems to be approaching to negative 0.985, right? So what if I jump in a haphazard way? What if I do 0.1 and then 0.03? And then I do 0.009. And then I do 0.00075. And then I do 0.00000, I'll just make it crazy, 643. Where'd my number go? If I'm getting closer and closer to 0, even though it's haphazard jumping, I'm adding in more and more and more and more zeros. Shouldn't they all be stabilizing to the same number? What the stink is going on, right? Like, what if we go to the graph and look at it? Doesn't look like that big a deal. Let's zoom in, right? Okay, whatever. There are asymptotes, so it's going to infinity. Wait, no, it was not going to infinity. You don't see infinity, do you? I don't see infinity. Huh. Okay, Okay, so we have to zoom in more. So zoom in more. Okay, so why isn't it going to infinity? Am I a degree mode?
Yeah, you are a degree. That's what
I
I'm
might be. Sorry, I was in free cal brain. Let's go back to my table and see what's going on.
Yeah, that makes more sense. I was like, how are the numbers so off?
You guys are so cute. At least you're awake now. That took a while. 1, 2, 3. 1, 2, 3. Is it stabilizing now? Oh, it is stabilizing. This is something different. You guys see it getting closer and closer to negative 0.306? No?
Yeah.
Oh wait, I didn't add an extra 0 to that. If not, let me know. 1, 2, 3, 4, 5.
Yes.
I don't remember how many zeros I'm at. I'm just making sure I know more. Then it starts to get really weird. So like, wait a minute, I thought I saw it getting closer, and now it's getting. And then if you do the haphazard jumping, it is going to kind of go all over the place because in our graph, oh, there he is. Yeah.
Oh.
And I'm zoomed super far in. Well, between negative 0.1 and 0.1. If I could zoom in more. And as you zoom in more and more and more, do you guys see this stabilizing towards one value? No? I see it. You see it stabilizing. This is between 0.03 and 0.03, and it's getting closer to one height. So, sure. We'll zoom out, just in case maybe we're too zoomed in. We'll zoom out just in case we're too zoomed in, because it just gets worse if we keep zooming in. I don't see that stabilizing. And the reason being, if you plug in, you get sine of 1 over 0, and we know number over 0 is what kind of form? Yeah, some sort of infinity form. And what sign of positive or negative infinity? Does sine ever stabilize to one value? So it's a dn. But when we went by the set jumps, didn't it kind of look like it was going to negative 0.3 something? Oops, wrong. Negative 0.3 something, something, something. So here's the hard part. Does the limit appear to be 7?
Yeah.
Does it appear to be 7? Yeah, look, closer, closer, closer. It appears to be 7, but the problem is we're going by set jumps. I don't know for sure. They didn't tell me how weird this function is. So is it definitively determined by a table? Nothing is definitively determined by the table, unless there's a theorem to back it up. And there is no theorem that we learned this chapter that said, if a table, as you approach 5, set whatever jumps, looks like a limit, will be a limit every single time. No, I just showed you a counterexample. It didn't work. Okay, so hard question, very hard question. But the silly thing is, not the silly thing. The challenging thing is, I should have seen everyone else's answer be right here. Does that make sense? Because that one was a no, and that one was a no. Okay, coming back. You guys see how the AP can be tricky?
Yeah.
No, they make you prove that you know what's going on. And they have a wide scale. Out of the 1s, 2s, 3s, 4s, 5s, the 5s is the biggest one. The 1 is the second biggest one. And then the other ones are split up in between. To get a 5, you only need to get 65% of their questions.
Where?
Wait, what?
Well, because you shouldn't be getting 65% on my tests. My tests are nicer than some of these, right? But for their questions, getting 65% right is them giving you the highest possible score.
What?
Go team. Now people get 80%, 90%. There have been some perfect scores on the AP exam. But, all that to say, there was one in California just a couple years ago. But anyway, down in LA, San Diego, something. He was not white, but I'm sure maybe. But all that to say, they give you a broad range. It's because their questions are tricky. So Adam, they don't want you to fail per se. They just make you prove it. All right, only 2 people got this right. Yeah, Adam and Kathleen. Nice. All right, feedback. The graphs of the function are shown above. The value of the limit. How do you take a limit? Aren't there properties that let us split this up as long as it's continuous?
Yes.
What's the struggle with that as long as it's continuous? F is fake. Yeah, F has some issues. Hold on. Okay, well, how could we really do this, right? Could we split this up to be the limit as x approaches 4 of f of x all over g of x plus 7 over g? That's just math, right, guys?
Yeah.
Okay. And then I can technically take it piece by piece as long as it's allowed. So let's see what's going on. The limit as I go towards 4 of g would be 5, right? What's the limit as I go towards 4 of f? If I were just doing that. Yeah. Remember, the approach, where is it approaching? 3. So, if you were doing this the easy-ish way, you would have just said, hey, I know him, and I know him, and let's plug it in. So 3 plus 7 is 10, and 10 over 5 is 2. You might have had some issues with this whole continuous thing, because then you would have been like, well, this guy's discontinuous, so does it fail my property, so I can't actually split it up? If you got stuck there, you definitely still could have done this one, because this one is just 7 over 5, so you could have had 7 fifths off to the side. The problem would have been this one, taking this function and that function. The nice thing is you guys could have actually made little equations for this dude if you really wanted to, because he's a line and he's a parabola. So you could have actually even made your piecewise functions. If you really wanted to double check, I would have gone 2. I would have put a star by it and come back to it. But you could have made an actual equation for your little parabola dude, because you could have done y equals ax squared plus bx plus c. And it's a piecewise. You have that for x not equal to 4, and then for x equal to 4, but you don't really care about him because he's the at anyway, so ignore that. And then you could have plugged in, how many points do you need for a parabola? I think it's like 3. So you could have plugged in like 2, 3, and 4, 3, which would have worked, and 6, 7. Because then a system of equations, and then you could have solved it. But that's only if you had time. Otherwise, you would have gone for the 2 and you would have moved on. I have seen times where, because of the nature of the graphs, it's not that easy. You need to come from below, you need to come from above and make sure they match up. But the nice thing is, if we come from below and above on this one, and done our work step by step, they're both in agreement, so we're okay, and it's all using limits, so we're okay. What got some of you in trouble was probably that you plugged in. You said, what's f of 4 plus 7 all over g of 4? And if that was it, you would have been stealing, the wrong one. You have to use the limit now. To be honest, that should always work. The only time it gets iffy is when we have compositions of functions, and on practice AP questions, I've only ever seen 2 that they made tricky to where that wouldn't work, even with the whole discontinuous thing. We did okay on that one. We did okay-ish on that one. I'm not saying great. I'm saying go check out the ones you got wrong. Just not as bad as that. Oh, and then we're done. Oh, guys, that wasn't bad. We only had, what, 3 or 4, where only 1 or 2 of us got it right. But do you still have, some of you, some stuff to work on? Go back, look over, and bring questions. But pause. Are AP questions harder than book questions and my questions?
Yeah.
Yes, so be thankful for, even if you didn't like the test yesterday or know that you got tricked on some, or still pondering the whole tangent of T over T thing. Yes, I give you some tricky ones. But it could be worse. My tests are such that you can get like an A, B, C, D. Specifically A, B, C in my class without me needing to curve everything. But I have to get you ready for AP questions too. Yeah?
Yeah, yeet.
Okay. Making sure we're all on the same page. This chapter is called Basic Derivatives. You can call it differentiation if you want. Or you can call it basic derivatives. That also works. Or you can call it basic derivatives. That also works. No, I wish. They do have, well, for the AP test, they do have AP graders. AP graders. In other subjects, well, for any AP grader, you have to have taught the subject at least 5 years, which I definitely have. But for calculus, there are so many people that want to do it because it really is a huge benefit. Yeah, actually honor if they ask you back or if they allow you back. Their teachers are telling them they don't get asked. But that's the problem with calculus. There are so many people that want it that there's a lottery, literally. Beyond the people that they've been asking back year after year after year after year, there's a lottery for anyone new that joins. And it's usually during AP grading, it's usually during when I take mission trips during the summer. So that's why I didn't do it for when I was initially available. I get to go like at the very beginning of summer to Florida for like a week, and it sounds fun-ish, and the people who've gone forever, like their friends are there because they've made friends, and it's like, hey, let's go and have fun at night and work all day. But you're literally like in a room for 8 hours grading one question.
One.
Oh, like multiple one?
Yeah, there are different rooms. I think there are different rooms for different questions, because the only thing that needs grading by hand are the 6 long answer. 6 long answer for AB and BC. It's all together, because 3 of the BC are the AB FRQs, and then 3 are unique or on new material. They have different rooms for questions. They have room leaders who have been personally trained and come early to be trained by the people who wrote the AP, but it was like a consortium. But there's every 3 years, 5 years, there's a new head AP guy, like head who everything goes through. But it changes every so many years. That way it's not the dictatorship. That's forever. And then underneath him is like a board, and then they train, he basically personally trains every room leader. And then the room leader trains all of the table leaders. And all the table leaders are the first place for questions from all of the people at the table that are grading the party. Yeah, I would enjoy doing it. It's just something that hasn't really been available to me, but I should at some point. But I go to math conferences and go to AP workshops where I get to meet some of these people, see them, ask them questions, etc. So I'm learning from them, just not directly in the grading. And it is the most desirable way of a teacher seeing as best they can what's on the AP is going to the grading. We'll see. Maybe someday. What's the word that's missing? Anybody figure it out yet? You've already seen the word, and you've already learned the power rule. What? Derivative. Yep. Derived.
I'm drinking the rat.
Yep. A lot of the jokes that go on calculus sweatshirts have to do with drive. Calculus is deriving me crazy. Don't drink and derive. That was a BC one. It was a very special. I'm not sure if they'd approve it again, but it was funny. What else? There have been a few. But anyway, slope of the tangent line, slope of the graph at one point, or instantaneous rate of change. All things that you guys in some way, shape, or form have seen before, but I need you guys to, in some way, shape, or form, star, highlight, make a point that this is only the description. This is only the description, the very common, colloquial, not very formal, not very technical description. The description. Okay, so let's get beyond that to the definition. If you notice, this one has a yellow box. Now, the description is important, guys. It's crucial. You need to understand the description because that's what's going to help you read a problem and know that it's saying find the derivative. We're going to use slope of tangent line. We're going to use instantaneous rate. We're going to use how fast at 1 point and not over 2 points. We're going to use all of them. The description words, however, it's crucial that you know the definition of the derivative as a forever card. Now maybe I should make a description card and a definition card just to make the distinction. But I'm hoping that you guys in your notes make a distinction and only one goes in the forevers. Why am I telling you this? Time after time after time, even after we make this forever card number, I'll get back to that. I'm still pondering making a forever 6 that's not this. But even though we're going to make this a forever card, I know I need to choose by today, just hold on. Even after we make this a forever card, even though I say study your forever cards, even though we have a forever card quiz, I still have kids at the end of the semester on the forever final, at the end of the year on the forever final, still be given, state the definition of the derivative, and they're like, tangent line. I'm like, no, that's the description. So what's the definition? The derivative of a function f at x is given by f prime of x is equal to the limit as delta x approaches 0 of f plus of x plus delta x minus f of x all over delta x. However, you don't have to use that one if you like the H notation better. If you like the H notation better, that's the one that you guys saw in pre-cal a lot more commonly. You just need to state for me, let H equal delta x, and then you can rewrite this careful. F prime of x equals. The definition of derivative always should start here. And I take off points if it doesn't start with f prime of x equals. So if you say let H equal delta x, then you say the limit as H approaches 0 of f of x plus H minus f of x all over the limit of the difference quotient as H goes to 0. Now last year you guys didn't learn limits until what, like chapter 12? The very last chapter of pre-cal? But you did see the difference quotient in chapter 1a. At the very beginning you saw the difference quotient, at the very end you saw the limit, at the very beginning and the very end of pre-calculus together, and you have calculus. Well, at least the beginning.
Oh, that was a year ago.
Yeah, isn't that weird? Oh, Abby's actually not here today. Sorry. I'll get this one. Sorry, I'm giving kids a test next period and asking them how many work for them.
You know, those big sections.
Okay guys, here's a dilemma. I need to name this forever card right now. If I name it 6, it will forever be 6 and there will not be any other 6.
It's just in the
Can we think about last chapter really quickly and the test that you just took?
Sadly, yes.
What was a very important topic that is not in your forever cards? We have basic, unit circle, and trig. We have all the basic graphs. We have the special trig limits, continuous, and IVT. What's something else that you guys saw on the test yesterday that you think you might forget how to do it as the year progresses?
Horizontal axis.
Yeah. Horizontal and vertical. That's the one thing I always debate making a card on. And I'm like, don't remember it. And then at the end of the year, I'm like, I didn't remember it. Here's a dilemma though, I have 49 cards. So that would put it at 50 cards, which is perfect if you don't make a mistake on it. Every card doesn't fall out. And someone didn't argue like this at their last card. I know people who literally like friends are like, yay, these are fun, and then it's like, now we're doing it because I want a number over 0. Check the sign. That'd be vertical asymptotes and then horizontal asymptotes. So this is going to be forever card number 7. This is forever card number 7. We're doing it. First year ever. It's going to be unique and different. You already are unique and different. It'll just be more unique and different. Which means you're going to skip a card to write this one down. Ah, did you just hear me? What are you going to do to write this one down? Skip a card, or just don't write it down until I give you forever card number 6, which we don't have time for today because I want to get a little bit further. But we will. Your homework isn't due until Tuesday. So technically you're okay. However, I want you to see what types of problems will be showing up in homework. This will be homework number 7, because the review is never a homework number. And we had 6 homeworks in chapter 1. So due on Tuesday. Okay. Okay. What are homework problems harshly going to look like? Well, what's it asking you to do?
Nothing. Derive.
It wants you to derive it. It wants you to find the derivative. And it says using the, some of your worst friends.
The limit process.
Pause. If you know the easier way, can you write out from the very beginning what you think it is?
Yeah.
Okay, what do you think it is from the power rule?
I think it's 10x.
If you know how to do the power rule, you would say 10x minus 7. That's it.
But
Derivative of any constant is 0. So how do you prove that you're right or that?
you put in the big long nasty
You say f prime of x is equal to, what are we doing, delta x or h?
h.
Alright. And then as h goes to 0
This is so
of
confusing with x's too.
5. Yeah, I know, the delta x and the x, that's a common confusion. Why am I writing it like this?
So you don't make mistakes.
Because what is the formula that I'm plugging into? Limit as h goes to 0 of f of x plus h everywhere there's an x. Some of you struggled with this in pre-cal. Compositions of functions, plugging something in to another function. We are going over that currently in pre-cal and honors pre-cal. The videos are online the same way you accessed them last year through my website. You can't get into their Google Classroom anymore, but you can get to my website where there is links to the YouTube videos. If you don't know why I'm putting an x plus h inside these parentheses, being squared in times 5, or inside these parentheses, you need to go watch section 1.8 compositions of functions videos. I'm describing it a little bit differently this year for the hopes of kids understanding it even better. But what's the name of the game right now, guys? What is always going to happen when you go to plug in for this limit?
Lots of math.
Plug in 0. Or plug in 0. Isn't it going to be f of x minus f of x?
Yeah.
Isn't that going to be 0? It's always going to be a keep going. Okay? It's always going to be a keep going. So how do we keep going? You guys okay if I FOIL this and I get x squared but times 5 and I get 2hx or 2xh but times 5, which would be 10? And h squared but times 5. You see it?
Yes.
And minus 7x and minus 7h. Why do I like that a lot of you know the power rule? Because you can double check and not make the silly mistakes. You can go to cancel out. All of the original function stuff should go away. Everything that remains should have a common factor of h. And if I pull out that h, because I'm keeping going, I would get 10x plus 5h minus 7 all over h. It doesn't match. Wait. What can I do with my h's? And how do I finish every limit problem?
You plug it in.
Which is why I rewrite limit every time so I don't forget to plug it in. 10x minus. Aha! Did you find it?
That was kind of fun.
Yeah.
You found a derivative for the bonus, or you didn't.
You just looked at the label.
I tried.
I solved it.
I'm talking about
It was super similar to this. But it's one of those where it's old math, but it's so tricky.
How do you do that monstrosity of man?
So how do you do this one? You don't know a rule, and even some of you that be like, I can make a rule. Don't. Don't. In calculus, the one thing you never do is make a rule.
Wait a minute, can't you just make it
No,
equal 1/2?
don't. It's a good idea, but you don't know how to finish it correctly all the way. Now, I'll show you what the final answer is. The final answer is going to end up being, because I know how to do it. I'm not bragging. I've taught calculus for a long time.
Totally better.
Some of you might figure out what this is, though. Hold on. Give me 1 sec. There you go. That's what the derivative is going to be. Negative 3 over 3x minus 1 to the 3/2 power. Yes, it has something to do with making that the 1/2 power and something to do with the power rule, but that's not perfectly it. What would you have to do to try to solve it?
Ugh.
You would have to plug it in a way that you would legally be able to reduce. So how do you guys think you're going to have to reduce this? Not conjugate yet because of the denominator issue. So complex fraction first, then conjugate, and then get out of your mind. You can start homework this weekend. And not all of them are this hard. I just gave you a hard one at the very end so that you're like, it's possible? Those of you guys did not take your AP classes, do it. Come to your class of credit nutrition at the very beginning. 125. Or if you want it now, you can buy it now. I don't care. I have a cancel.
Oh,
Take it. Oh yeah. Like the half or Folgers. Get more Starbucks.
Friday the 13th.